Hello everybody, here we are, and this is not sort of actually, this is gonna be around an hour long live in which we are just simply gonna be discussing about we are gonna be actually designing the, what? We are gonna be designing a URL shortener, and that's just gonna be the theory part. That simply means on a high level we are gonna be discussing the things, how many things we are actually gonna need, how we are actually gonna be scaling it, how the data distribution is gonna work, and all. So these are the things that we are gonna be talking about. Okay, so ultimately a server is gonna be distributed, database is gonna be distributed, and how the overall things are gonna be working, and how the back of the envelope calculation is gonna be happening. So almost all the basic things that are actually, am I audible? Back of the, yeah. So almost all the basic things that are actually needed, we are gonna be going through all of them. So without any further delay, let's simply get going, and I'm gonna be going to eraser, not eraser actually, xcal idraw would be better, xcalidraw.com. So by the way, welcome back. As it's being possible for me to just simply go live more and more, so I'm just simply going live more and more. And of course, in past few days, of course, it's been a bit hard. By the way, let's talk about the HLD, high levels design, and we are gonna be talking about over here, that's gonna be URL shortener. So sort of shorter, no, I hope that's the right spelling. Okay, so this is what we are gonna be discussing about here, and just a minute, give me a sec. That's gonna be this one, and this one. Alright, we're talking about the things that we have covered so far. So we talked about normal architecture, especially I'm talking about the things that I've learned. So we learned about, I learned about normal architecture, exactly how the things are architected and all, how you distribute the servers, how you distribute the databases and all. Then there was something called cap theorem, so we learned about that. We learned about the back of the envelope calculation. We learned about monolith versus microservices and all. Then the most important thing, that is DB sharding. So how you can actually scale the data. So we talked about that, and especially when it comes to the DB sharding. So there are two ways, and whenever you are sharding the data, so hash ring actually, that is called hash ring is used, and we call hash ring as consistent hashing. So consistent, again, these things are not gonna make any sense if you have no idea about them, but hash ring uses something called consistent hashing. Using consistent hashing, we can just simply shard the database and all. Ultimately we can create multiple instances of the database. Then we have the load balancers as well, and load balancers have some of their algorithms. So load balancers are used for balancing the load. They have some algorithms. There are static load balancers algorithms, so static, and there are dynamic ones as well. So dynamic, again, these are just the algorithms, so I may keep them in my mind, I may forget them as well. It depends. By the way, as for the algorithms, static algorithms, so there is a round robin algorithm. Again, all these things are not related to the current topic, but still discussing them here. Okay, so this is the first one. Then second one is the weighted round robin algorithm. Will not be talking about them, but overall round robin algorithm means round wise you just simply distribute the data traffic, especially when it comes to sending the data to the servers. Weighted round robin algorithm, that simply means it takes the ratio of the weighted round robin. So on the basis of their capacity, you just simply you send the traffic to those servers. And the last one is the IP hashing. So IP hashing means you will get the IP address of that particular user. You are gonna be just simply hashing the ID, then you will get a number, and you will be hashing the IP. You will be getting a number. Suppose any number, you may get any number here after hashing that. Once you get that, you will be just simply getting the modulo by the number of the databases that you have. So if I have 3 databases, so I'm gonna be just simply getting the modulo using 3, and this way you are gonna be getting some remainders, and that remainder is gonna be the number of a modulo. The remainder can be anywhere between 0 and 3. So this is how it's gonna be going on. So these are the some of the rules for static load algorithms for the load balancer, and there are some dynamic ones as well, and if I haven't forgotten them, so there is something called least lol, I forgotten. I think what is the first one when it comes to dynamic? Least connection, probably this is the one, least connection method. Let me have a look at this. Probably I'm forgetting this. So when it comes to this, so we have least connection, well, that's right actually. I was a bit confused, but yeah, this is right. So least connection method, that simply means whichever has the least connection, just simply send the request over there. But it doesn't talk about, I mean care about the load that the server actually has right now. And then we have weighted least. So weighted least connection method. This simply takes care of two things. It first of all it gets the ratio of the number of connections and the ratio of the weight of that particular machine, like what is the capacity of that particular machine. As per that, it just simply decides where to send the traffic. And then we have the third one is gonna be least response method. Least response method or algorithm, call it anything. It just simply checks the least response, so whichever ultimately it will get the number of requests that it has, and then the overall average response that it takes to resolve those requests, it will just simply multiply them, and whichever has the lesser least response time ultimately not even how should I put in words. So ultimately you will have two things over here. You will have number of requests, I mean pending requests, and then you will have average response time over here. You will just simply multiply both of them, and similarly you will have many, because there are going to be many databases, and once you just simply multiply them, so whichever has the least amount, the request will be forwarded there. As simple as that. Here I am talking about merely the database. So this is how it just simply goes. And lastly we have one more, and that is called resource method. Okay, this is a resource method. This can be the this resource method ultimately, or algorithm, simply uses the resource in the sense it uses the CPU, it uses the current uses, so it uses the number of requests. So ultimately it just gets the data about your server. On the basis of that thing, it just simply decides whether to send the traffic there or not. And mostly you have agents running, so on your server you have agents running. Those agents are responsible for telling you about the server, I mean the kind of the traffic, the situation of the not situation the load that the server is actually going through right now, or it has. And on the basis of that thing, load balancer decides whether the request should be sent to that particular server or not. So these are the things. We have mainly two static and dynamic load balancers, and this is how the things actually go on. So yeah, we have sort of talked about load balancers as well. Again, no need to keep them in mind, I mean it's good to have them in mind, but it is not like you have to remember them or something. Just know that these types of load balancers are there. As you keep practicing, you will automatically remember them. So this is the thing that we have gone through. And then the next thing that we talked about, that is rate limiting. So when it comes to rate limiting, so again over here you have some of the algorithms. When it comes to algorithms of rate limiting, so the first one that you actually have, that is token bucket, if I'm not wrong. So what happens here, that a request come, and they just simply, if the token is there, just simply get the token and they get forwarded to the server. If there are no tokens, they don't get forwarded. And there is a token builder that keeps building the tokens in a fixed interval. So this is the first one. Again, I will not go into depth of them, but overall we can just have normal talk. Then token bucket is here. Then leaky bucket is also here. Leaky bucket in the sense, there's gonna be there's gonna be a request pool. So suppose there are many requests, and there's gonna be a queue. That queue can only contain probably 3 requests. So 3 requests are gonna be gonna be going into the queue, and now the queue is full, so remaining requests, they are gonna be dropped ultimately, and those 3 requests are gonna be going to the server. So this way, in a fixed interval, the queue keeps getting suppose your server can handle 3 requests at a time, for example. So the limit of the queue is gonna be 3. So there can be only 3 requests in the queue, and they will be going to the server one by one, and they will be getting resolved. And once the queue is empty, then it will keep getting more and more requests. And if it actually has a lot of traffic at once, then only 3 requests are gonna be accepted, remaining ones are gonna be just simply dropped. So this is how it just simply goes. So we have this one, leaky bucket, and then apart from this leaky bucket, we have fixed the window counter. We have fixed the window, and what is the full name? Fixed window. Again, I forgot the name of it. Let me see what the name of this one is. Okay, let me see. Fixed window counter. Yeah, this is called fixed window counter. So what it does that it just simply divides the time in intervals. Fix the windows. So suppose if you are, that can be those can be windows of seconds, or those can be windows of minutes as well. So suppose you have divided the time into minutes, and now in 1 minute there can be fixed number of requests that can come. If there are more requests, it will not allow them. So this is how it just simply goes. There are downsides of this as well, like on the edge cases, as your window is about to end, that 1 minute's interval is about to end, you got many requests, and then when the new interval is started, you got many requests. So there's edge case problem. Then you will have multiple requests at the same time, and it will be hard for the server to just simply manage the just simply process them at the same time. Again, we could have gone through all these things in detail, but that's because we already have something URL shortener to discuss in detail. Hence, I'm talking about these things just verbally here. And then we have sliding fixed window counter. The problem with the fixed window counter is that it has edge caches problem. Just know more about it. It will be good. So edge caches issue, problem. It has edge caches problem. For getting rid of that problem, we have sliding window log. So what happens that in here, in this particular case, your timing is fixed. It starts over here, it ends over here. When it comes to sliding window log, your 1 minute window, it just keeps sliding, and that is why it has sliding window log. So what happens that as you get the request, you just check the request in 1 minute before, 1 minute ago. So suppose at this particular time you got the request, you will check the request 1 minute back, how many requests you got. If those requests are more than the limit, then again the request is gonna be dropped, and if they are lesser, then the request is gonna be accepted. Ultimately, suppose if 3 requests are accepted at a time in one window, in 1 minute window. So if 3 requests are accepted per minute, in that particular case, suppose at some time, this is the time. Let me even draw this, that would be better. So this is the timeline that you have. This is where you got a request. So from here, 1 minute back you will be checking. So suppose this is the 1 minute window. So till here you will be checking how many requests you got. If the request is 2, that is still less than 3. So that particular, the new request will be accepted. If the request is already 3, that will not be accepted, and that simply means your request is gonna be dropped. But for this particular thing, you have to simply log them. That simply means you will have to keep the logs of the request of the previous 1 minute, and hence, or previous timer. Hence, you will have to maintain the logs. You will have to save them, and because of that thing, it's gonna be slower. First of all, it will consume the resources of your server. So, but this is how it just simply works. So this is the, and then lastly we will combine both. So we with the fixed window counter, we had a edge caches problem. With the sliding window, we have logging problem. Ultimately, it will consume the server. I'm gonna be combining both of them. And the next kind of algorithm that I have, that is sliding window counter. So what happens over here, that you still have a sliding window sliding window. So suppose at this particular time here, you just simply, probably somewhere here you got the request. So as you got the request over here, so you will have fixed windows here. Fixed windows in the sense come on, can I delete it? This is the first window of a minute. This is the second window of a minute. This is the third window of a minute. Okay, just something like this. Let them be here. And then the fourth window, fifth window. And ultimately, this is how the windows, they just simply keep going on. Suppose you got the request over here. So what will happen now? You will check that. I mean, not here actually. Let me delete this. It may be possible that you got the request exactly on the edge case, but probably suppose you got the request over here. Let me change the color of this as well. So for example, this is the request that you got. So this is the overall interval that you have, right? This is the 1 minute interval that you have. So you are going to be checking the number of requests before the interval. You will be checking the number of requests after the interval, and after that you are going to be just simply use this formula and calculate. So number of previous request plus number of post request. So how should I put it in words? I'm not getting the idea. How can I just simply explain this? And maybe I'm even getting confused regarding this particular thing one. So these are the intervals first of all, and then you got a request. As you got the request, you may get the request. Okay, the thing is that we are in the same interval, so that's simple. Ultimately this is gonna be the only one interval, and hence yeah, number of the request number of request in previous window ultimately, and number of the request in the number of request in next window, and of course you are gonna be dividing it by percentage, like whichever percentage it has covered. Percentage, just like this. Okay, forget about this formula, let's talk about this thing over here. So what is that? What I'm simply saying that as soon as you got the request, so you are gonna be getting the number of request in the previous counter. In the previous counter we don't really have any request, and then in the current counter we have all the requests. That simply means we have all 100% requests. So over here the percentage is gonna be 100%, and the number of requests depends exactly what are the number of requests you have. Suppose we have 3 requests are allowed at a time, and over here we have suppose 3 requests. So 3 requests multiplied by that's gonna be confusing. Okay, let's see, let me make it something like this, because if 3 requests are allowed at a time, and over here we already have 3 requests in this one, and it keeps sliding, it's fixed, and in the previous we don't have any, ultimately sort of 0. So let's get the percentage like this: number of the request in the previous window multiplied by percentage, exactly how much it has covered, and then you have number of requests in the next window, and that is it. So if I just simply use this particular formula, so number of the requests, they are 0, ultimately percentage, that's sort of 0 percentage, so forget about that. Number of requests, they are already 3, hence that's gonna be equal to that, so it will not accept the more request. Okay, suppose it was something like this. Okay, and I actually got the request somewhere here. So I got the request at this particular point of time, and when I looked back, so suppose there were 2 requests here, there was 1 request over here. So in this particular case, number of the previous requests, that's gonna be 2, and suppose that actually covered around 33, 66, around 66% or 67%. So I have to get this much, and plus 1 request. So if I just simply calculate this, so the calculation is gonna be 2%, 67 and plus 1. So and max 3 are allowed, or I could have even made it 1 for simpler. So 1, 1 and 3 requests are allowed at a time. So if I'm making it 1 here, so 67%, 67 divided by 100 multiplied by 1 by 100 the other side. So how much is it? 67 divided by 100, that's gonna be 6.7 or something. So we have 0.67, and once we have 0.67 plus 1, that's gonna be 1.67. So ultimately 2 requests we have right now, if we just simply get the props. So we have 2 requests and 1 is just remaining. So this way you can just simply go ahead, it's pretty crazy. Let me just calculate it another way. Suppose 5 requests are possible, and here we have 3 requests before and 1 request after, or probably 2 and 1. Let's make it 3. So 3 and 1. Now if I try to calculate, so previous requests, there are 3 requests previously, and suppose 3 to 4, 100%, 25, 75. So 75%, suppose time has been covered here. Just for example, it doesn't really matter. It could even be 50%. 50% time got covered. So the time depends on the timing. So this 67% or 50% that I'm gonna have over here, that is about the time. So if I have it over here, how much time has been resolved in this particular interval, ultimately window, and how much time is remaining over here. So suppose it is 50-50. So 50% time of the previous window is remaining, 50% time of the next window is remaining, it is right now. So in this particular case, I have 3 requests and percentage 50%. So 50% of, yeah, that's right, 3 multiplied by 50%, the remaining portion that you have 50% right now, plus 1. So if I just simply try to calculate this, 50%, that's gonna be 1 by 2, ultimately 3 by 2. If you try to get it, so 1.5 it will be, and 3 by 2, 1.5, yeah, that's sort of right, and plus you have 1, so ultimately you will have 2.5, and as this value is less than 5, hence that particular request will be allowed. Let's make it suppose 5 this time, 516 you have, it cannot be 6, let it be 4, so 415, and this time if I make it 4, and suppose 50% time is remaining, so that's gonna be around 2, and hence 2 plus 1, that's gonna be 3, and 2 plus 1, that's gonna be 3. In this particular case, that is still less than 5, so that should be allowed. Let's know more about this particular algorithm from ChatGPT. That would be better. So ultimately what happens here, that in sliding window algorithm 2, that you have number of requests in the current interval and number of requests of the previous interval, and then the percentage. So the formula is sort of right, but I'm still not sure about this. Okay, I don't have proper understanding of it, so I'm gonna be just simply asking AI to explain me this. Tell me about sliding window. What was the name actually? Just a minute, give me a sec. So tell me about sliding window counter algorithm of rate limiting. That you are talking sliding window algorithm used to rate limit. So rate limiting means how many requests a user can. Okay, that's right. Max 100 requests per minute. Problem with the fixed window. So we have already talked about it. Before sliding window, people use the fixed window. The time is divided into fixed slots. Okay, close this. Fixed slots like 1 minute. Counter resets every minute. Issue a user can exploit. So suppose at this particular time, this is called the edge cases that we just discussed briefly. So at 59 send 100 requests, at 1 minute send 100 more requests. So ultimately you have 200 requests in 2 seconds to just simply handle. Sliding window counter, then we talked about this. We even had sliding window log, but okay, let's not worry about that. Instead of fixed blocks, it smoothly tracks the request across times. So it combines previous window, current window. So we calculate it like this. So previous window count multiplied by remaining ratio. So what is the remaining ratio? In our case, we assumed that it was 50%, and then current window count. So current window count means what? How many requests are there? So intuition, all requests gradually lose weight. So previous window count and remaining time ratio plus current window count. So new requests get fully weight. So traffic becomes smooth, not spiky. Let me see. Let's say okay, limit is 100 requests per minute. Current time is 30 seconds into the window. 30 seconds into the window. So previous window count 80 and current window count 20. Huh? Okay, it just simply telling me about the number of requests. So the total limit is 100, and the current time is actually 30 seconds. In the previous window there are 80 requests. In the current window there are 20 requests right now. So effective 80, 30 by 60, 30 by 60. Now what is this plus 20? I have no idea how it's actually calculated, and how we actually get I mean the number of previous count, window count or current window count, and how we actually calculate the percentage and all. Tell me everything clearly. So it turns out this is gonna be the topic of the day. Okay, of course we have to go through that URL shortener, but before that let's simply go through it really quickly. So when data, data do we actually store? So we do not store every request like sliding log. We only store two numbers, two numbers plus time. So current window count, previous window count, and window start time. What does this mean? A window, suppose a window size is 60 seconds. It is still okay. So time is divided like this: 0 to 60 seconds, window 1, 62, 122, and 3. So these are the windows. Counts are maintained. Current window count, number of requests in current window. So this is the first window, this is the second window, something like this. Then number of request, previous window count, number of the request in just previous window. So that's fine. Current window and the previous window. How values update? Request comes in same window. So current count is gonna be plus plus. Okay, so window changes when time across boundary. So previous count, window count, current window count when time crosses boundary. So whenever the boundary is crossed, so previous window count actually becomes current window count. That's right. Current window count, that's gonna be 0 for now, and window start time, current time actually starts over there. Makes sense. Example timeline, this will clear everything. Let's assume 100 requests per minute. Window is 60 second. So first window 0 to 60 second. User sends at 0 to 60 seconds 80 requests. So in the first window, user is actually gonna be sending 80 requests. So current window count is 80, previous count is actually 0 for now. That's right. Step 2, new window starts at 62, 160. Now previous window count is 80, current window is 0. Step at 75th second, 15 second, new window. A user sends 20 requests. So current window count is gonna be 20. That's right. How percentage is calculated? Find how much time passed in current window. So time passed in the current window, that's gonna be current time minus window start. So the current time when it actually started, window current time, that the current time that you have, and window start time, that simply means whenever the window started. So ultimately I'm gonna be getting 15 sec over here, for example. So 75 minus 60. 75 is the current time, minus 60 is the window start time. That's right. So find remaining weight of the previous window. So remaining is gonna be window size. This is gonna be weight of the previous window. So remaining time ratio, that's gonna be window size and minus time passed. So window size 60. That's right. Time passed, that is around 15 seconds. Divided by window size, that's again 60, and hence it will be this much, meaning previous window still contributes 75% of the weight, but it's still recent. So final formula: previous count, window count plus remaining ratio, that's actually the remaining ratio. So whatever the remaining ratio is, it could be 0.75. again we still have to calculate this. Okay, and the current video and current window actually, and hence decision effective count is less than allowed. That here 80% are allowed. Intuition very important. Previous window is fading away slowly, current window is building up. So one important thing, that is, first of all, these are the number of requests that you have here. Coming back to this one. So ultimately over here the formula is this, that previous window count plus percentage. So ultimately ratio, or how much it has actually been passed. So coming back to this one, so this is the formula anyway. So if I just simply copy it from here to here, so effective count is gonna be previous window count multiplied by remaining time ratio. So what is the time that is remaining on the previous window? So you have to calculate the time, and current window count. And this is how, if you just simply go through it, you are going to be getting the result. Having said that, whenever uh, when it comes to this one, so suppose previous window count, that's around 80 in our case, that's right. Current window count, that's 20 in our case. Now we have to just simply know about this thing, remaining time ratio. So in the previous one, how much time is remaining, so and this time was calculated like this. So now how percentage is calculated, so this is the main thing. Find how much time has passed in the current window. So time passed in the current window, so the current time that I have minus the window starting time. So 75 minus 60, so suppose it was 75 seconds minus 60, 15 seconds. So 15 seconds have passed in this current window right now. That simply means remaining time 45 seconds are in the previous one. So 45 seconds are in the previous window that are remaining, divided by 60. So it will be telling me what is the percentage of the time that is in the previous window. Once we got that percentage, suppose 75% is still previous window has is covering, so we are gonna be just simply multiplying it by 75%. So 80, 0.75 plus 20, that's gonna be around 80. And decision, if effective count that we got, if it is less than 100, allow it, as this is 80, hence the requests are gonna be allowed. And if effective count is greater than or equals to 100, they are gonna be rejected. So 80 allowed. There's one more problem here. It is saying that at 80 it is allowed, but you are saying that 100 requests are allowed at a time. In the previous window, 80 requests was there. 80 requests were there, and in the current window we have 20 requests. So if we actually add them, they are already 100. And when we get effective count, that is actually 80. So if we actually count the number of requests directly, so previous window has 80, current window has 20, that equals to already 100. So it should not be accepting any more requests. And when we calculate effective count, it actually comes 80, that is actually less than 100, so it is gonna be allowed. So how it makes sense and how are the things connected? Okay, let's go through it the last time, then I'll call it. This is exactly confusion, blah blah blah. Okay, so your thought, which seems correct but isn't. Previous has 80, current has 20, total is limit reached, should block. This would be correct only in fixed window, but sliding window is not equals to simple addition. So the core idea you are missing, not all previous requests are still valid. Okay, some of them are already old, should not fully count. Think like this, very important. At 75 second, previous window 0 to 60 second, yeah, current window 60 to 126. Now ask, are all 80 requests from the previous window equally recent? No, right? That's right. Request at 0 second, very old. Request at 59 seconds, very recent. That makes sense. So what do we do? We decay reduce the previous window count based on time. So visual time, this is the key. So previous window is 0 to 60, current window is 60 to 120, current time is 75. Distance from previous window 15 sec into new window. So previous window is getting older, that's right, it is. So weight calculation, so remaining weight 60 minus 15, that's gonna be 45, and 0.75, this is the percentage that is remaining in the previous window, means only 75% of the previous requests are still relevant. That makes sense. So instead of counting 80 fully, 80 becomes 80 multiplied by the percentage, that's gonna be equals to 60. So if I have 80 requests but only 75% is in the second window, so the overall calculation is gonna be like this, and 60 requests are still valid in the window. That makes sense. Some requests are already expired in influence, that's right, and hence 80, that is already less than 100, and the new request is gonna be allowed. Got it? So this is how it works. By the way, 75% was remaining. If 0% was remaining, in that particular case, if I talk about it like this, that suppose right now I'm just simply saying that in the previous window we have 75% yeah, ultimately we have 1 minute window, right? So if I make it like this, let's just simply draw a proper diagram, that would be better. So what it is saying that you have a, come on, you have a timeline here. Simple, I have this timeline here. In this particular timeline I have multiple I mean time intervals, I mean time windows. Ultimately suppose they are 1 minute windows. So this is how I'm gonna be going ahead. And suppose what happened that I'm gonna be maintaining 1 minute's ratio. So suppose this is gonna be 1 minute window. Let me even take the width of it. So this is the 1 minute. Uh, this is, suppose this is just nothing but the duration. It represents the duration of a minute. Now what happens here that I got a request over here, but before that I have to assume. So suppose if I this is 0 second, this is 60 second, this is 120 second, and it just simply keeps going on. Suppose I got a request at 75, so somewhere here at 75 I got a request. That simply means somewhere here I got a request. Okay, that makes sense. So as I got a request at 75 second, of course, so previously in the previous window I had 80 requests. In the current window I have 20 requests. As simple as that. So previously I had 80, right now in the current window I have 20. So in the previous window, that simply means this whole window I had 80 requests. In the current one, right now I know how many requests I have, 20 requests. Now I have to see, as this time is keep increasing, I mean it just simply keeps increasing, and sometime it's gonna be 120 second. So suppose at 75 second I got 20 requests. So now I have to see, we already know the number of the previous requests, so it actually starts from here. So I have to see how much this portion is covering, because of course as the new request came at 75 second, and if we go 1 minute back, so 1 minute back in the sense till this point it becomes 1 minute. So all these requests are gonna be old, and all these requests are still gonna be in that minutes window, right? So what do we have to do? We have to get the number of requests that are old, and we have to get the most important thing is that get the number of requests from the previous window that are still active, right? So what we will do that ultimately total we have 100 requests allowed. So 100 requests are allowed in 1 minute. We have this is the thing, the limit that we have. Once we have this particular limit and we have 20 requests in the current window, then what do we have to do? We need to have few things: previous window count plus percentage ratio. Percentage, ultimately what is this percentage? Remaining time ratio, remaining time percentage or ratio, call it anything, plus current time requests. So ultimately this gives me the number. First of all, I have all the previous window count, that simply means all the requests from the previous window, and then I have the ratio. So if I just simply multiply ratio with the previous count, then I will be getting all the active requests, and I'm gonna be adding all the active requests to the current request. Hence what will I get? All the previous active requests, all the current active requests. If the number is less than 100, and if this number is gonna be less than 100, then the new request is gonna be allowed, otherwise new request is not gonna be allowed. As simple as that. Now what do we have to do? I already have the number of previous count 80, I already have the number of current count 20. What is the time that has been passed? So the current time is 75, the previous starting time was 60. So 75 minus 60, that simply means 15 seconds have passed over here. So 15 seconds have passed over here. Overall the window that we are maintaining, that is 1 minute window. Hence 60 minus 15, that's gonna be 45 seconds that are in the previous window. And if we actually get the percentage, so 45 seconds means what? So 45 divided by 60, so we are gonna be getting around 0.75. Let me see, 45 divided by 60, so yeah, we get 0.75 here. So we get 0.75, that simply means 75 percentage window is still remaining. That simply means 75% out of 100. If there were 80 requests, so 80% 75% of 80 requests are still valid. So for getting the number of requests, what I'll do, I already have this calculation anyway. So previous window count, that is 80, plus remaining time ratio, that is 0.75. This much will give me the previous active requests, plus I have the current time, current requests, that are 20, and this is gonna be around 80, 0.75. That's actually gonna be around 60 plus, let me see, 80 and 0 multiplied by 0.75. That's gonna be 60 actually. So coming back to this particular point, we will have 60 plus 20, that's gonna be actually 80, that is still less than 100. That simply means the request should be allowed. Let's try to change the numbers. Changing the numbers in the sense, suppose the time is actually gonna be this time, this much. Let's make it 110. This is the second. So at 110 second I got the request, and over here suppose I got at 110 second I got, for example, 90 requests. Not 90 is gonna it's gonna be many in that particular case. Let's keep it 80 for now. I'll increase that number. So suppose 80 requests I got here in this particular interval. Okay, that simply means how much time has been passed though. So from 60 to 110, that simply means 50 seconds. So 50 seconds have been passed. That simply means in the previous window we have 10 seconds remaining, and we have to check the number of requests. So 80 and 10 seconds means what? So 50 seconds have passed over here. So in the previous window, 60 minus 50, 10 seconds, 10 divided by 60, that's gonna be 1 by 6. How much is it? 10 divided by 60, that's gonna be 0.16. So what I'll do, 80 multiplied by 0.16, that's gonna be 12.8. So overall 13 requests are still, so over here in the previous window 13 requests are still active. So 13 plus 80 requests, that's still around how much, 93. It is still less than 100, so it's gonna be valid. But if I had 90 requests, not 90, 80, so 7 requests can be there. So let's have 87 over here, and if I have 87 requests in the current window, so that's actually gonna be 87 over here. Hence that will not be less than it's gonna be actually 87 1300. That will not be equals to that will not be less than 100. That simply means this particular request is gonna be dropped. Wow, good calculation stuff. So this is how it just simply works. So we had a few things over here, not a few things, these algorithms you can call them: token bucket, leaky bucket, fixed window counter. Pretty simple. Sliding window counter, the sliding window log. Actually the problem was here that you had to maintain the logs, you had to save them to just simply check the previous number of the requests previously. And then we got this sliding window counter. It just simply maintains the it has first of all fixed the intervals, fixed the windows, first one, second one, third one, and it even maintains the previous, it even checks the number of requests in previous minute. So for that thing, it suppose it got the request at 110 seconds, so it will just go back like 1 minute back, and it has two windows. It has this previous window, it has this current window. So it already knows the number of requests in the current window. Now it has to check how many requests were there in the previous window. So current window request plus previous window request, if that exceeds the limit, then of course the requests are not allowed. If that doesn't exceed the limit, the request is gonna be allowed. So this is how it just simply goes on. Pretty simple. Okay, by the way, coming back to the main point, these things were just simply extra because we have to go through completely different thing. But okay, good that we talked about all these things. Never expected that I will get stuck going through this. And then we have caching related strategies as well. So let's not worry about it. Let's simply start talking about this designing URL, because if we just keep digging deeper into them, so it will just simply keep going on and on. So what we want to do, we want to generate a URL shortener, and of course we have to just simply create the high level design for it. So suppose what will I will have a just simply long URL. I have a long URL. Then what I'll do, let me do it like this. This is how I'm gonna be going on, and long URL. So this is the long URL I have, and I will send this long URL to my server. So my server is gonna be having this server. So this is the server of mine. It will have this long URL, and once it has this, I will send the long URL to my server. My server will just simply short it. So this is how it's gonna be going on. So it's pretty simple. Like overall analogy is simple. So we'll have short URL here. So this is how the things should actually go on. But behind the scene, many things happen, and let's start going through them one by one. Okay. Again, this was over here. We need to know a few things. First of all, how many people are gonna be using our application in a day? Even keeping that aside, how many URLs? Because when you are generating an app, before that you need to have the idea exactly how many people are gonna be using it. So let's have some questions. So first of all, how many request people we are targeting? So suppose there are gonna be 20. Again, this is just the example, like what I can say. This is just an estimation. It could be anything. It could be 20 million, 30 million. So suppose in our case, we just want 20. Again, this 20 was used by one of my instructors. So I just took this example so that I don't get stuck in between in the calculation. So it would be easy, but you can choose any number. So suppose we are going to be having 20 million requests. So ultimately 20 million people are going to be there. So ultimately, what can I name it? People, because if 20 million people are there, they are gonna be creating 20 million requests. So 20 million. So there are gonna be 20 million people, and suppose one person creates one URL in a day. So ultimately, we have to make sure that our server should be able to handle 20 million writes per day. So 20 million writes are gonna be, at least one person is gonna be creating one URL. It will be converting one long URL to short URL. Again, this is nothing but the assumption. I mean, it could be anything. It could be even 2 over here. So 20 million people are there. They are going to be using creating 2 links. So 20 million multiplied by 2, 40 millions. But okay, let's keep 1 billion here, 1 here, because not all the people, even if I have 20 million people, it's not like all of them are going to be creating the URLs daily. Some of them will create. So, and some of them may create more than 1, maybe 2 or 3, and some of them may create nothing at all. Hence, considering that at least one user creates 1 request per day makes sense. Okay, so this particular thing is done. So ultimately, what will happen? 20 million ultimately 20 million writes are gonna be there in our database, in our DB. So in our DB, we are gonna be saving the 20 million requests per day. Now we have to even check how many requests we are gonna be getting per second. That's easy calculation. We can do that. The second thing is that this is the first thing. What should be the length of your URL? And it should be as like as short as possible. I mean, it's not like, I mean, you can decide the length of your URL, but in our case, the length of the URL should be as short as possible. And as for the characters, because there are gonna be characters that are gonna be used in the URL. So when it comes to characters, so I want to use 0 to 1, I want to use A to Z, small a to Z, and I want to use capital A to capital Z. And if I talk about the number, so 0 to 1, 10, plus A to Z 26, plus 26, that's gonna be around 64. Really? 26, 26, 52, 62 actually. Okay, so these many characters we can have. I mean, these are the characters that we can actually use. So this particular thing is done as well. So we have gone through this. So what is gonna be the overall flow? The overall flow is pretty simple. The user is gonna be just giving me the URL, wrong URL. I will just simply I will give it to my server. My server will do whatever it has to do. It will just simply create a short URL. It will give me the short URL. Now whenever I just paste the short URL in any website, I should be redirected to that particular wrong URL automatically. So this is how just simply it's gonna be going on. Let's talk about, this is one of the important things. I was actually scared of it. Now I'm getting a bit habitual in the habit of doing it, and this is called back of the envelope calculation. Back of, I mean, we even call it BOE, back of the envelope calculation. calculation, and you can just simply keep it anything. What do we do here? We just simply calculate the stuff, not even calculate. We assume कि okay, we have 20 million writes per day. Okay, so 20 million writes per day in the sense how many writes are there in per second. So ultimately I'm gonna be knowing about query per second. So you can even say a request per second. It's completely you up to you what you want to name it. First one is gonna be either you say R request per second. So RPS or QPS. RPS means query per sec. RPS request per second or query per second makes, I mean, both of them do the same thing only. So if I have 20 million requests, 20 million requests per day, so how many per minute? So in that particular case, what I'll do for calculating this, I have 20 million. So 20 million in the sense, again, there's one thing that you have to keep in mind before you actually get into the calculation. That is how to name it. We are gonna be working on the basis of the 2 to the power. So whenever we just do any calculation, we'll make sure that at the end of the day we are gonna be coming back to this 2 to the power thing. Okay, and 2 to the power n, that can actually be anything. So we'll have to make sure that whichever number we have, we should be able to ultimately convert that number into 2 to the power n format. Okay, so this is gonna be our goal. And when it comes to this, so I'm gonna be writing the n over here. So this is where n is gonna be mentioned. So 2 to the power 10 or 20 or 30 or 40 or 50. Okay, let's name them exactly what they are called. So this is nothing but the n over here. And when it comes to 2 to the power 10, that is simply called that is actually equals to 1000 to the power. It is not a exact number, it is approximate, but we do not consider the exact numbers. We are approximately just simply calculating the stuff, because when it comes to 2 to the power 10, that simply means 2 to the 4 to the 2 to the 4 to the 8 to the 16 to the 32 multiplied by 32. So 32 multiplied by 32, come on, yeah. So it is approx 10 to 1024. So it is not exactly 1000, but it is approx 1000. So 10 means, this is called, first of all, what do we call it? Megabyte. I forgot the name, crazy. I hope this is called a megabyte. Megabyte, yeah. So this is in terms of storage. So this is called megabyte, and this is 1000, 1000, and then we have 20. This is gonna be called after megabyte. What comes after megabyte? Crazy. Let me do one thing. 2 to the power n conversion rules in but what are we doing here? Back of the envelope calculation. I should be able to see that somewhere. It's hard to remember them, I mean. Okay, never mind. So yeah, here we are. So 10 1000, that is actually called kilobyte. Yeah, KB, it actually starts from here. So this is called a kilobyte. I mean, this is I mean, all these words, kilobyte, first of all, they are mainly this kilobyte, megabyte. This is important when you are working with the storage. You have to calculate the storage, so this gets important. And then 1000 is called 2 to the power 10. That simply means 1000. That is equivalent to kilobyte. So we call it kilobyte. Okay, and we can even make it like this. 1000 means 10 to the power 3. As simple as that. Okay, and then what is the next thing? The next thing is 2 to the power 20. That is a megabyte. Megabyte, and that is how much? 1 million, if I'm not wrong. Let me have a look over here. If I'm 1 million, that's right, and that is called 1 megabyte. And short name can be 1 KB, 1 MB. 1 million approximate value. So 1 megabyte has 1 million bytes 1 KB has 1000. No, bytes, not bits. So how many bits are there in 1 KB? How many bits are there in 1 KB? I think it is all about bits. No, this is, so 1024 bits equals to 1 KB. So 1 KB kilobyte to bit. Byte 1000. So 1 kilobyte has 1000 byte. Wow. So we are talking about byte. That's 1000, right? So we are mainly talking about byte over here. So ultimately, when it comes to kilobyte, so it has 1000 byte. So this actually represents the storage stuff. Again, 1 byte contains 8 bits. So this is how it just simply goes on. So we have 10 to the power 2 to the power 10, that is kilo, that is called kilobyte. In short, we can call it KB. And again, this is gonna be 1 KB here, 1 kilobyte, and that is equivalent to 1000, and that simply means 10 to the power 3. Then we have 10 to the power 20, that simply means megabyte. Megabyte in the sense how many bytes. Kilobyte, it has 1000 byte. Okay, megabyte will have 1 million byte. I mean, it just simply keeps increasing like this. So megabyte 1 million, that is gonna be approximately that's gonna be equals to 10 to the power 6. Then we have 2 to the power 30, that is called gigabyte, if I'm not wrong. So gigabyte, so how many bytes does 1 gigabyte has? Again, it is called 1 GB, gigabyte. Let me have a look here. So the next one is definitely called gigabyte. I'll have to make sure that I'm writing the things the right way. So that's gonna be 1 MB. So 1 MB has around 1 million bytes. 1 MB that you talk about, because 1 KB has 1000 bytes. 1000 bytes, 1 KB. That's insane. I mean, even thinking of this makes me crazy, that 1 KB has 1000 bytes. Let me search it one more time. How many how many bytes in 1 KB? Not DB actually, KB, 1000 bytes. So 1 KB is equivalent to not even 1000. 1 kilobyte equivalents to 1024 bytes. Wow. And 1 byte has 8 bits, so it will have 8000 bits. Wow. I mean, it's insane. I mean, thinking about this is insane, that 8 bits are equivalents to 1 byte. Okay, 1 KB has 10 to the power, I mean 1024 bytes. 1 KB, and 1 KB is really small. I mean, really small. And then 10 to the power 6, that ultimately 1 million byte is equivalent to 1 megabyte. So ultimately, what I mean, that 1024 bytes equals to 1 KB. Then 1024 KB is gonna be equals to 1 megabyte. 1024 megabyte, that's gonna be equals to 1 GB. 1024 GB is gonna, yeah, that's a good calculation stuff. I mean, crazy stuff. I mean, this science. First of all, it actually starts from 8 bits, that's gonna be equivalent to 1 byte. Then 10 to the power 24, I'll give it to the AI to just make sure it is correct. That's gonna be 1 KB, kilobyte. And then 10 to the power 24 KB, that's gonna be equals to 1 megabyte. And then 10 to the power 24 MB, that's gonna be 1 gigabyte. Then 10 to the power 24 GB, that's gonna be 1 terabyte. And 10 to the power 24 TB, that's gonna be 1 petabyte. Petabyte, PB, I don't know what goes after this. PB. So GB, TB, PB, and then we have even exabyte, EB. That's not mentioned here. That should have been. Anyway, so never expected. Seriously, my main goal was building this, but here it turns out that I'm not. My foundation is not as strong as it should be. That is why we started discussing about all these things. And then 10 to the power 24 PB. That's gonna be equals to 1 EB if I'm not wrong. Exabyte. Let me give it to the chat GPT. Is this right? What a bhai, kacha. I mean, yes, your list is correct, but important detail you should understand. What you wrote correct in binary system, your values follow base to binary. So 8 bits 1 byte. This is how computers actually work internally, because of binary 2 to the power 10 this, but there is a cache, very important. There are actually two systems: binary system, what you wrote, RAM operating systems programming 1 KB did this, megabyte 10 to the power this, or technically KIB is called kilobyte, MIB is called technically called KIB, KB byte, maybe byte, GB byte. Decimal system used by companies, hard drivers, internal speed and storage. So why this causes confusion? You buy 500 GB hard disk, companies uses decimals. So 500 GB this bytes. So 500 multiplied by 1000, 1000, 1000. Okay, fine. But your OS uses binary, so 465 GB shown. That's right. So final understanding. Just a sec. You buy 500 GB hard disk. Your company uses decimals. So 500 GB. So 500 multiplied by 1000 converted into GB to MB, MB to KB, KB to bytes. So these many bytes. So that simply means 5000 bytes are there. Yeah, but in reality, in our this is how companies they calculate it. And when it comes to real applications, so ultimately, or CPU and all, or system, for the companies, 1000 is gonna be equals to 1 KB. 1000 byte is equivalent to 1 KB, but in on real application, 1024 bytes are gonna be equals to 1 KB. Hence, it just shows less. Okay, got it. But remember, 10 to the power 24 used by computers, 1000 used by companies. That's what I've been saying. Okay, pretty good. So we've gone through this particular thing. Am I facing the network issue? Nope, not really. Great, yaar. I mean, I ended up learning a lot of things. This is how the things go on. Okay, coming back to this one. So 10 to the 2 to the power 10, that simply means kilobyte, and 1000 bytes. Ultimately it contains 1000 bytes, and ultimately it will have 10 to the power 3 bytes, just like this. That's right. Okay, continue from here on. Then we have 20 to the power 20, that is simply called megabyte, 1 MB. It means 1 million. That simply means 10 to the power 6 bytes. Coming back to this one, we have gigabyte, and 10 to 2 to the power 30, that is the gigabyte, and it is 1 trillion if I'm not wrong. 10 to the power 9 bytes. Going forward, we have 2 to the power 40, that is equals to gigabyte, then terabyte, so 1 TB, and that is equivalent to now 1 trillion. What next? After 1 trillion, what comes? After 1 trillion, quadrillion, 40 trillion. Let me see. 40 should be trillion. I forgot one thing. It should be billion. Sorry, that's my bad. So million, then billion, and 10 to the power 9. Yeah, 10 to the power 9 is actually called a billion. That was my bad. And then 1 terabyte, that is gonna be 1 trillion here. And 10 to the power how much? Trillion contains how much? Leh, I'm gone. How much is trillion? 10 to the power how much? Uh, that's not mentioned here. How much is 1 trillion? Calculate it now. 1 2 3 4 5 6 7 8 9 10 11 12. So 10 to the power 12. Okay, 1 trillion means 1000 billion. So ultimately I'm gonna be adding 1000. So 9 plus 3, that's gonna be 12. 9 10 11 12. Yeah, that's right. So this is how the calculation actually go on. That's interesting. Something new is discovered here. 10 to the power 3 plus 3 6 plus 3 9 plus 3 12. This is how it goes. So it is just 1000 is added. So 12 bytes makes sense. And then you will have 50. And now this is gonna be called quadrillions. I hope the spelling is right. This quadrillion, copy paste, that would be better. So quadrillion, that simply means 1 QB, if I'm not wrong. That's gonna be equals to 1. I mean, now after trillion what comes, I don't know. This should be petabyte first of all. Petabyte. This should be called 1 quadrillion. That's gonna be 10 to the power 10 to the power how much? 10 to the power 15 bytes. So 3 6 9 12 15. That's 3 1 3 3 2 6 3 3 9 3 4 12 3 5 15. As simple as that. Now there's one more thing here. 2 to the power 60, that is actually equals to exabyte 1 EB. 1 EB is how much? My grammar is crazy. How much is 1 EB? Exabyte. 1 exabyte EB is a massive unit of digital data, typically defined as 1000 petabytes. That's right, but okay, that makes sense. So ultimately we've done it, right? Haven't we? So this is gonna be 1000 petabytes. So how to 1000 peta 1000 quadrillion this is how it just simply goes, and it is equals to 10 to the power 18 bytes. Here we are. We've gone through it, haven't we? Let me give it to the chat GPT if it can check it. Sorry. Copy it as PNG and now give it to the chat GPT. How's this? But two small improvements. Okay, 10 to the power 3 6 9 12. This is perfect for decimal units. Hard drives, and we are talking about hard drives only. Mistake 1 QB. You wrote petabyte. That's my bad, sorry. Let me correct that. Oh yeah, PB, it should be PB, sorry. If it is equals to petabyte, so it should be this. Exabyte, then where is QB? Yeah, QB, quadrillion bit. We just call it petabyte, that's right. So if I go to this particular thing here, so 1 quadrillion is actually called petabyte here, so that makes sense. And what are the other errors here? Correct is gonna be PB, and then mistake number 2, 1000 quadrillion. Yeah, that's right, I did that. This is confusing and unnecessary. So 1 quintillion, crazy name. 10 to the power 18 is equals to this. So instead of having it this like this, let me have it like this. So 2 to the power 60, that is actually equals to 1 quintillion. Such a good thing. I'm happy to have it here. So this is how it's gonna be going on. and these are the bytes related things. And what do I do in this particular case? I just simply copy it as PNG, and I go to my nodes. Quickly, and probably I need to go to till the end, and here I need to paste. So I just try to keep everything safe for future reference, as simple as that. So we have gone through this. Anyway, let's come back. Let's come back to our main calculation. So we were trying to calculate the request per second or the query per second, and that's pretty simple. So ultimately, how many queries we had in a day? We had around 20 million queries, right? So 20 million, and as I said, we have to convert everything in the base 2 format. So 2 multiplied by million means what? Million means 2 to the power 20. Million, billion, yeah, 2 to the power 20. If you don't know, if you are confused here, it is, so 1 million is how much? 1 million is equals to 2 to the power 20. That is why you have to have this particular thing in mind. Then the things get easier to just simply go through. So 2 to the power 20, and once we have this much, we have to know how many queries go per second. Okay, how many seconds are in a day? So that's equals to, in a day, right, seconds. So 60 multiplied by seconds, 60 minutes, 24 hours. Think again, how many seconds are there? So there are 24 hours in a day. 24 multiplied by 60 minutes multiplied by 60 seconds. Simple. There are 24 hours. There are 24 multiplied by 60, these many minutes. 24 multiplied by 60 multiplied by 60, these many seconds. Calculate them. 24 multiplied by 60 multiplied by 60, that's around 86,400. Okay, so this is actually equivalent to 86,400. These many seconds we have in a day. Now we have to get this calculation done. So what do we have to do? Pretty simple. That what pretty simple? 2 divided by 86,400. That's it. So clear it. 2 divided by and 86,400. We have this much. Control C. So what is the calculation here? This multiplied by 2 to the power 20 still. Okay, let's calculate it even further. So not this, should be 20 actually. Now if I want to have at least 3 digits here, so at least these many digits, so 1 2 3 4 5 6 7. Okay, so that simply means if I write it like this, 231.148, not 48 multiplied by 10 to the power 10 to the power, of course, how many digits we have come back? So 1 2 3 4 5 6 7, 10 to the power minus 7. Okay, minus 7 multiplied by 2 to the power 20. Okay, this is done. Now we have to convert it into the base 64 format, and 10 to the power minus 7 does not make any sense. We have 10 to the power 6, that is called a billion. So sorry, yeah, billion, sorry, million. So we have 10 to the power 6, that is called a million, but we don't have 10 to the power 7. So let's do one thing, let's have digits still here. So we will call it 23.148. So once one digit back, hence I will have 10 to the power 6 and multiplied by this. Okay, that's fine, it was already there. So I just converted this whole thing into this particular format. Now if you just simply calculate it, so it is equivalent to what? It is just simply saying that 10 to the power minus 6, that simply means it's gonna be divided. So if I divide 23.148, let me even do this. So not this, come on, I should be able to do that. 23.148 divided by 1 2 3 4 5 6, कहाँ गया हूँ, sorry, divide it. So this is equivalent to the same number, right? So how many 0 are there? 1 2 3 4. How many 0 were here initially? 1 2 3 4. 4 0 over here. So yeah, it is right, the calculation is right. And once we've done this, then we have to convert it into the base 2 format, right? So that is the most important thing. And 10 to the power 6 means what? 10 to the power 6 means 1 million. 1 million means what? 1 million means 2 to the power 20. If you actually have a look over here, so we have 10 to the power 6. 10 to the power 6 means 10 to the 2 to the power 20. So you will have to always convert probably sometimes base 2, I mean 2's power into, ultimately, how can I put it in words? Sometimes you will have to convert from base 2 format to base 10 format, or sometimes base 10 format to base 2 format. I hope I have explained it well, but I'm not sure about this particular thing. Okay, so ultimately it's gonna be equivalent to 23.148 multiplied by 2 to the power 20. 2 to the power 20, but it's not gonna be 20, it's gonna be minus 20, because of course haven't I made a mistake here? Let's see whether I made a mistake or not. Okay, and multiplied by 2 to the power 20 I already had here. If I made a mistake, I will be checking it back. And then we just simply got 23.148. Now let's see whether I have made a mistake or not. So we had 2 million. With the 2 million, we had 20 million. That is what I was thinking. Why am I getting 23 only? So we had 20 million, since it's gonna be 20 over here. Hence there's gonna be one more 0 over here. Sorry, not one more 0. If we divide it now, so how much will I be getting? 20 divided by that. So 20 divided by 86400. That's actually gonna be, there are gonna be 3 zeros. Interesting. So there are gonna be now 3 zeros in this. That's fine. Hence the calculation is gonna be this dot is gonna be here. Hence this dot is gonna be here, and hence this is gonna be here. So these many requests, so 231 requests per second. Here we are. So these many requests go per second. So we have calculated the request per second, and apart from this particular thing, what else do we need to calculate? So we have to check these are the write requests. So ultimately write requests. Now we have to talk about the read request. So let me even have it here actually. This is the calculation for the write request. So in a second we just save 231 links in the database in a second. And if I talk about the read, so suppose if we have one link, so in 1 second it has 1 to the power 10 or 20. If you have really a big application, it could be that if there is one link, in one link is being saved, 20 people are using at the same time. In our case, let's assume that 10 people are using. So links are gonna be created less, and people they are gonna be being used many times. Hence the ratio we are gonna be maintaining over here, that is 1 by 10. That simply means one link got created, and 10 meanwhile 10 times it was queried. Okay, so that simply means this is gonna be read requests. So how many times we are gonna be reading using those links and all. So in that particular case we already had 231 multiplied by 10, that's gonna be 2031 2310. So these many requests. So these are the read requests that we have over here. Even we can have the peak requests. So there is something called peak requests. So normally we will have these many requests per second, and when it comes to the peak requests, that's gonna be to get the peak request, we can just simply multiply it by 2. So 231 multiplied by 2, that's gonna be around 462. These are the peak requests that we can get. I hope so, that is the right thing. And this is how it's done. Coming back to this one, can I just simply search for wow, that's amazing. Never expected I would get it in this particular format. good, but okay. Peak query per second. So yeah, call them peak request or call them peak query per second. Peak query per second makes sense. So coming back to this one, this is not gonna be peak, this is gonna be peak query per second or peak request per second. So they can be 462 requests per second. Of course they are gonna be the peak one, so just double it and that's gonna be the peak value. And these many read requests we get per second. And when it comes to peak query per second, that's gonna be 2 3 10 multiplied by of course 2, that's gonna be around 462 this much request per second. They can be the peak. So normally you get these many requests, write requests, and then you can get these many can be the peak requests. So you are just simply doubling that. So okay, we have calculated this as well. Now let's talk about the storage. Like so far we have talked about read requests. Can I change the color of it? The whole color is gonna be changed. That's insane. So let me go back. So we have talked about this particular thing. So ultimately requests are done. Now it's all about storage. Storage is gonna be pretty simple. Storage, let's simply go through it as well. So when it comes to the storage, so for how many years you are gonna be calculating the storage, so you have to keep that particular thing in mind as well. So suppose for further coming 5 years we want to calculate the storage. So if you want to calculate the storage for 5 years, so just assume let's talk about the write request, because of course we have to save the data. So when we are writing only, then we need the database. So per second, forget about per second, in a day we get 20 million requests, as simple as that. So in a day we get 20 million write requests. So 20 million write requests we get in a day, per day. Now I have to calculate it for 5 years. So 20 million multiplied by this is what in a day. So 24 multiplied by 365 multiplied by 5. So this is gonna be for 5 years. Yeah, that makes sense. So how much is it gonna be? 20 million means what? 2 to the power million billion, 2 to the power 20. And then 24 multiplied by 365. Why am I having 24 over here? One day I don't need to have this 24 here. So in a day I got these many requests. There are 365 days in a year, and there are 5 years. So ultimately it should be like this. Yeah, that makes sense. So 20 2 to the power 20 365 and multiplied by 5, this much. Now let's calculate. So how am I gonna be calculating? To calculate these many requests I'm gonna be having in a year. So to calculate this, 20 did this. Let me just use the calculator again. So that's gonna be 20 multiplied by 365 multiplied by 5. Just a minute, let the calculator appear. If I just simply add this, not add, actually multiply. Sorry for sneezing, probably I'm suffering from sneeze. So 365 00. Interesting. So we got 365 00 multiplied by 2 to the power 20. Now how much can it be? These are the number of requests we get in a year, and to make it simple, we have million here. We can make it billion. Billion means 10 to the power 3. We can get 3 more requests. That can be converted. Just a sec. Come on. Hold on. We can convert it like this. 35.6 multiplied by 10 to the power 3. Can't I do it like this? So 10 to the power 3. So 1 2 3. Yeah, that's right, 10 to the power 3. Now we have 10 to the power 3. How much is it? It is equivalent to 1000. That's right, 1000 is equivalent to 2 to the power 10. What? 2 to the power 10. The word I'm forgetting. Kilobyte. Yeah, let's have a look here. So 10 to the power 3 bytes, that's equivalent to 2 to the power 10 kilobyte. That simply means we can write it like this. So instead of writing it like this, Now because my main goal is gonna be, why did I convert it like this in this particular format? Because I had to first of all bring it in the base 10 format, so that I can convert that base 10 format into base 2 format, as simple as that. So 35.6 multiplied by, now 10 to the power 3 means 2 to the power 10 plus multiplied by 2 to the power 20 we already had here. Now if we want to calculate it even further, so 2 to the power 10, 2 to the power 20, that's gonna be 2 to the power 30. So 35.6 multiplied by 2 to the power 30. 2 to the power 30 means billion, billion, yeah. So 35.6 billion. These many requests we will get, these many write requests we will get in 5 years. 5 years down the line, and they are gonna be write requests. So ultimately these many URLs, 35.6 billion URLs we'll have to save in our database. Pretty simple. That's cool. Let's continue. It's crazy color. Okay, let's go with this only. So now what am I gonna be doing? These many, I know the number of requests that I'll be getting in 5 years. Now how much? So suppose I'm storing a URL, and that URL suppose has 100 byte, the size of the URL. So in that particular case I have 35.6, that is around, okay, let's have it like this. So that's actually sort of gonna be storage here. So storage is gonna be equals to 35.6, of course billion, multiplied by, if one URL has takes around 100 MB. 100 MB, isn't it? It is too much. 100 MB. 100 byte. One character has 2 bits, 2 bytes. So the size of a one character, one char, is 2 bytes, right? So if there is a URL, that URL can have max 50 characters. So 50 char, and even 50 char is a lot. That may have 20 characters, or even less than that. That's gonna be the short URL. Suppose the short one will have 15 characters, the long will have 30 characters, and plus there's gonna be some data, extra data. So ultimately it's gonna be around 50 multiplied by 2, that's gonna be 100. So yeah, let's suppose that it will have 100 bytes. So the data of one URL, that will at least need 100 byte space. It can be more than that, of course. It depends on you exactly what kind of data you are storing. In our case, we are assuming that we have 100 byte. Now again, we'll have to convert this 100 byte into 10 to the power format, so that we can convert that 10 to the power in the 2 to the power format. Okay, so for this particular thing, this is already a byte, and usually if I want to convert it into 10 to the power, so it is already 10 to the power 2 anyway. So 35.6 and multiply billion multiplied by 10 to the power 2, we already have it here. But 10 to the power 2 means nothing, so we'll have to make it 3. And if I want to make it 3, in that case I have to make it like this. So not like this, 0.1 multiplied by 10 to the power 3, equivalent to 10 to the power 2, because or I can even say that 10 to the power minus 1. Minus 1. This fly is bothering me. Okay, so it's gonna be sort of like this. We had 100, that means we had 10 to the power 2. Ultimately, initially we had 10 to the power 2. Then I said I want 10 to the power 3. So I said okay, that's fine. In that particular case, let's have one minus power here as well. So that's gonna be sort of, but literally, okay, we'll have this much. So 10 to the power 3 multiplied by 10 to the power minus 1, that will be equivalent to 10 to the power 2. And this 10 to the power minus 1 can be called as 1 by 10. That simply means 0.1. And this is how the overall calculation is gonna be like. Okay, that's fine. Now we have to just simply calculate it. So for calculating this, we'll have what? 35.6 multiplied by billion. That simply means 2 to the power, how much? 2 to the power 30 multiplied by 10 to the power 3 means what? 10 to the power 3 means 2 to the power 10, because 10 to the power 3 means 1000. 1000 is equivalent to 2 to the power 10 kilobyte. So that is also we have done, multiplied by 0.1. And now if I calculate it all, so how much will it be? Let's see. So first of all, let's talk about this particular thing. So this is actually gonna be how much? 2 to the power 30, 40. So, and we have to even calculate this. So there's already one. So it's gonna be 3.56 if I'm not wrong. Yeah, 3.56. We are calculating it even further. Okay. Okay, this thing is ultimately what I did. Let me even do it directly. We have what? We have 35.6 multiplied by 0.1. That's 3.56. Yeah, right. 3.56. Ultimately, one dot is here. One dot is here. Two dots we need to have. We are gonna be having two dots over here. Okay, multiplied by 2 to the power. That's gonna be 40. 2 to the power 40. Now, how much is 2 to the power 40? That's 2 to the power 10 kilobyte, 2 to the power 20 million megabyte, 2 to the power 30 gigabyte, that's billion, and 2 to the power 40 trillion, that's petabyte. So 3.56, sorry, terabyte, yeah, not petabyte, terabyte. So this is how it's gonna be going on. Coming back to this really matters a lot. If you, as you keep working on this will be there in your mind. But 2 to the power 10, 20 megabyte, gigabyte, terabyte, then we have the terabyte, then we have petabyte, then we have exabyte. It just simply keeps going on, and the more you work on it, the better the easier it will get for you. And that is it. We've done the calculation as well. So 1 terabyte. So this is again gonna be 3.56 terabyte space we need for a year. So now we will have to design our database in such a way so that the database has 3.56 terabyte space, so that it can handle the whole writing operations and all. So this is the BOE calculation that we have done here, like back of the envelope calculation that is done. And now what is the next thing that we have to focus? Seriously, I'll kill it. Now the thing is that with bare hands I cannot really catch it, but that's crazy. Okay, never mind. So we have done the this calculation. We even talked about this. We even talked about this most important thing. I mean, this is, if you want to get the calculation done, you need to have this particular thing in mind. Even I have done it in the best way possible, written it in the best way possible. Now the important thing starts from here, that how will you be designing everything from here on. Everything. So let's start working on. I don't really wanna take a break, as we have started working on this. So let's simply get it done in one go, and then we'll call it, right? So it's gonna be just simply simple like this. So what is gonna be the goal? The goal is gonna be pretty simple. That bro, you will get a long URL in the server. You have to just simply convert it to the short URL format. This is how it's gonna be going on, and then your server will be giving you the response. We have already written it at the top, right? So you will be getting the long URL, server will get the wrong URL, server will convert it, will give you the short URL, and then as you get the short URL, you have to just simply be redirected. Whenever you click on that, you will be redirected, as simple as that, to the long URL. So this is how it's gonna be going on, and especially when it comes to redirection. So there are two things. Suppose there are few things that I want to talk about. Status codes ultimately over here. Status codes. When it comes to this, so there is something called 429 status code that simply says that your request got dropped. So if when you are actually working with the rate limiting and all, and if you are dropping the request, so that's gonna be, if your request gets dropped, so it will have 429 status code. Then we have 301 and 302. 301 means if you are using so whenever your server creates the short URL and it just simply gives you the short URL, right? So server may give you 301 response, server may give you 302 response. What is the difference between them? If server gives you 301 response, that simply means whenever the next time you will be using this particular short URL and you will be just simply pasting in your browser, So the result, this long URL will be cached in your browser. So the next time whenever you just enter this particular short URL, so the request will not go to the backend, rather the caching data will be used, and this is how it's gonna be going on. And then there is something called 302. That's gonna be temporary redirection. That simply means whenever you just simply paste the short URL on over here on the internet, or of course on any browser and all, so the data will not be cached. That simply means the short URL and this long URL, this information will not be cached. Hence, whenever you just simply enter the short URL on the browser, you will be redirected to the data server, and the server will check whether if this particular short URL has any long URL in the database. If it has, it just simply gives you back the long URL, and the request will be sent to the long URL. So 301 means the data is actually gonna be cached on your browser, and this means it will not be cached. And most of the time people use 302, because if you are actually caching the data on someone's browser, that simply means whenever they are gonna be using this short URL, the request will not come to your browser, right? So the server that you have created, you want the request to go through that server. Why? So that you know about the uses of the user. So ultimately you know about the users, how many users are using your service. So for that thing, you would want that whenever this short URL is clicked, the request actually comes to your server. Then from the server, it is redirected, right? It should not be redirected directly because of the cache. Hence, for 3002 is used. You can use 3001, 3002, depends on you. But this was something extra that I just simply wanted to highlight over here. By the way, going forward from here, how do we decide? Just a sec. 302. That's already we have talked about this, so no need to worry about it. Let me see if I'm missing something. That's right. Okay, we've gone through this. Now if I copy it from here, hey, seriously, that's right. Suppose I send the long URL to my server. Now the question is how my server will actually store it in that, of course, in some kind of database. That can be SQL database, because when I send the request to my server actually needs to store this somewhere, right? So let's talk about the DBs here, databases. So when it comes to DBs, so we have two DBs. We have SQL databases and we have no SQL databases. In no SQL databases, we can use MongoDB, but as we are saving to two things, we have long URL and we have short URL. So whenever I click on the short URL, whenever I send the short URL to the database, it should be able to find the long URL. So the first thing is that you could use something called hash maps. So what they do, they just simply map the thing. So you will have short URL here that will be mapped to a long URL. Again, this is not what we'll be using, but this is one of the things. And for it, you can use the service by Amazon, and that is called Amazon Dynamo or something. Okay, Amazon Dynamo. I hope that's the name of that particular service. If I'm not wrong, correct me if I'm wrong here. Okay, I hope that service is called Amazon Dynamo. What does it call? I hope that's the same thing. So Amazon provides this for getting the hash maps and all. So this is again, this comes under no SQL if or SQL. What kind of this is? This comes under no SQL, right? DB hash map. There's no structure, so no SQL, because it doesn't have any table. So yeah, that makes sense. So you can use this particular service as well. And but the thing is that the problem with this is that ultimately what you will be doing, you will have a table, not a table, you will have a hash map here that will be divided into two formats. Over here you will have the key, over here you will have the value, and the key is gonna be short URL, the value is gonna be long URL. And that's right. I mean, this is how you can just simply have the things. But there is a problem. The problem is that whenever you are sending your whenever you are sending your short URL, ultimately clicking on the short URL, the request will reach the server. Server will check using the short URL whether the long URL exists or not, and it will be just simply sending you the response. But when you are actually creating the URL, ultimately creating the short URL, at that time you will send a long URL to the server. When you are sending long URL to the server, so server needs to check whether this particular long URL actually exists in your database or not. and hence it will not be able to look for the long URL directly because it is key value pair. Hence only with the keys you can look for the data, and because of that thing that's gonna be problematic. And to resolve this problem we will have to create two maps here. One will have a short URL mapped to long URL and long URL actually, so that you can actually check whether the second one will have long URL mapped to short URL. Now why it is needed, I'm gonna be talking about it. So a long URL will be mapped to short URL. Why? Because look, first time when you are creating your URL, short URL, so you will send your long URL to the server. Server will receive that long URL. Now server needs to check whether this particular long URL already exists in the database or not. And in that particular case you need to have long URL as a key, so that using that long URL as a key it can find whether it actually exists or not. Hence we need to have this particular table. As for this thing, now this is not actually a table, this is a NoSQL kind of map, key value pair. And when it comes to clicking on the short URL, so once you got the short URL, now you will click on the short URL, the request will go to the server will check whether this particular short URL actually exists in our database or not. For that particular thing you need to have this map. So that is why you need to have two maps, and this is not feasible of course. And apart from this particular thing, if there are many many values, many URLs, then it's gonna be time taking because it will have to just simply look through all of them, and then we'll check whether they actually exist or in the database or not. So it's gonna be resource consuming. Okay, but this is also one of the ways that you can use. The second thing is that of course we cannot use this belongs to NoSQL category, so NoSQL. So ultimately you can use something called Dynamo from MongoDB, or not MongoDB, from AWS for creating key value pairs and storing it. Second, if you are thinking of MongoDB, that is NoSQL again, but it will not make any difference. Like creating the MongoDB, even if you have MongoDB database, then that simply means that's gonna be a document type, right? It will have your short URL, then it will have your long URL, just like this. And this way there are gonna be many documents. Now if you get whenever you send the short URL, you can use this as well, but this is not gonna be as can we use this? Suppose I'm gonna be saving it like this. So in that particular case, whenever I send a request, okay, so suppose I sent a request, then I matched the short URL. Once the short URL got matched, I'm gonna be redirecting this particular long URL. That makes sense. You can do it. Why not? I mean, and whenever you are sending the long URL, you are gonna be checking using the long URL whether that exists or not, and you are gonna be returning a short URL. Let me ask ChatGPT regarding this, because in terms of getting the result, it will work. In terms of scalability, giving the result and taking less time and all, that's something I'm not sure about. So if I'm working on a URL shortener, and what do you think? Using MongoDB will be fine here, or I should switch to SQL database? Let's see what it's gonna say. This is exactly kind of system design matters. Both MongoDB can work. Yeah, that's what I was thinking, that both of them can actually work. But for URL shortener, SQL is usually the better choice. Okay, that's fine. What does a URL shortener need? Core requirements: store mapping. So short code should be short URL should be equals to this. So first lookup ultimately should be able to optional expiry, blah blah blah. MongoDB. Yeah, that's what I was just simply saying, that you can have it like this. Proj easy to no strict uniqueness, less strong consistent, and join and list get messy data. Ultimately you can use any database for that sake, but SQL is a bit better. So let's simply go through that. Even SQL you can have primary keys. So SQL it is just simply saying that Proj perfect fit for this problem, strong uniqueness constants, fast Index lookup, acid guarantees, atomicity. I forgot the full form of this. What is the full form of acid? Acid full form in SQL, of course. Atomicity, consistency, isolation, durability. Okay, never mind. But yeah, you can have something like this. And where was I? I was here. And then simple data model, no nesting data. Yeah, that's right. So you can use MongoDB, you can use Dynamo by Amazon. You can use I mean, if you want to maintain keep it in the key value format, you can go with the Dynamo. If you want to keep it in the document format, you can use MongoDB. And at last, you can, if you want to keep everything in the table format and index that, you can use SQL. It's completely up to you. But as per this SQL's SQL databases, they are better for this particular case. So we are gonna be using SQL. So you can use MongoDB. That's what and this is gonna be short of the structure is gonna look like. So we have talked about this. You can use any one of them. Database is a database. It will do the job as long as you have configured that well. And but we are gonna be taking SQL here as for the use case. So when it comes to the SQL, that simply means we'll have a table like this. We'll have some keys here in them. And that's gonna be, come on, can I delete it? Yeah, this is gonna be the first one, and this is gonna be the second one. Ultimately you will have the ID over here, so that's gonna be the ID, and then you will have a short URL, call it anything, it depends on you, but you will have the short URL over here, you will have long URL over here. And the good thing is that now you can query short URLs directly, you can query long URLs directly, and this is how the overall table is gonna look like. Pretty simple one. So this is how the database is gonna be selected, and we are gonna be using SQL over here. Okay, now the important thing comes, like when it comes to scalable projects, scalable servers and all. So you will have multiple servers, first of all, this particular thing. Then you will have multiple databases. That's right, there's not gonna be like there's gonna be only one database, there are gonna be multiple databases. So what how we are gonna be using multiple databases? For that thing we will be using consistent hashing. Now what is this consistent hashing? This is not the right time to talk about it, but we covered this earlier. Like I haven't really talked about it, or I can search it online anyway. Consistent hashing. Ultimately what you do over here, that wow, close this, so many of them are open. Okay, coming back to this one, I was just simply talking about the consistent hashing. Close this, and this as well. Now this is well. So I was just simply saying that consistent hashing has something called hash ring, just like this. In that particular hash ring, you just simply divide the hash ring in 0 to 100 numbers. So suppose 0 is here, 25 is here, and 50 is here, and 75 is here, 100 is here, and then you just simply place the databases. So suppose db1 is here, suppose here, then db1, db2 is here, db3 is here. I mean, this is how you just simply, I will not be explaining it, but overall this is how things go on. db4 is here. So this is how you just distribute the databases. Not only that, you create the replicas of that. So the replica of db4, unfortunately I think my inverter is beeping right now, so I have to just call it right here. I'll continue from here on. I cannot go further from here on, because of course my what I cannot even pronounce that. My inverter that is not charged yet, so I'll have to just simply call it. I'm gonna be catching up soon. Until then, take care, bye bye, and see you.